Hello students, greetings to all. Yes, we were discussed a few concepts in the last class, right? So there we had studied the right hand thumb rule, and which says about whenever if we are holding a current carrying conductor, right? The thumb finger which always shows the direction of the current, and the other four fingers which are wrapped around the conductor, which gives the direction of the magnetic field, right? And this right hand thumb rule, which is also known by Maxwell's corkscrew law, isn't it? So all these things we were discussed in the last class. So in this session, in this video, we will see how does the magnetic field lines patterns will be arised when a straight current carrying conductor, right? Of course, we know that in different shapes of current carrying conductors, right? Here I have mentioned here this straight conductor. In a straight conductor, the magnetic field line patterns are different. Then if I consider the circular magnets, right? If I consider these circular current carrying conductors, even the patterns of the magnetic field lines produced by that circular pattern, circular coil, which is also different, right? So as we have seen in the different shapes of the magnet, right? We have seen the bar magnet, and we have seen the different shapes of patterns, and horseshoe magnet, which produced the different shapes of patterns. Then in circular magnet, of course, we have seen the different shapes of magnetic field lines. Similarly here also, let us find out how actually the magnetic field lines they are produced in a straight current carrying conductor, right? So here, for that, first let me consider a rectangular cardboard sheet, right, which is placed here. Here it is. So what I do, so I can consider the conductor which passes or which placed perpendicular to this cardboard sheet, and this conductor which is connected by rheostat, right? This is called as rheostat. So let me give some name here. I can simply write RH. Of course, we know that what is the function of rheostat, right? So rheostat is a variable resistance which changes the resistance throughout the circuit, right? By changing the resistance, isn't it? By changing the resistance, what else changes? Current changes, right? We are very familiar for this, I hope, isn't it? We are familiar for this. Now this is called as RH, and here is the plug key, and I can take the battery over here to pass the current. See, here I can consider the battery, and which has positive polarity and negative polarity. Let me write. So here I can give some polarities for this. So here is the polarities. I can write here, this is plus positive end, and here is negative end, right? When the plug key is closed, right? When the plug key, if I close the plug key here, okay, see, if I close the plug key, the current starts to flow from positive end to the negative end of the battery, isn't it? We know that. So whenever the current starts to flow in a conductor, so from we already know that whenever the current carrying conductor which produces the magnetic field surrounding by it, isn't it? We have learned this concept. So now this is the current carrying straight conductor. Now once the plug key is closed here, see, the once again we can see here. So once if I close the plug key, see, if I close the plug key, then the closed circuit, as a result, the current flows through here, and as a result, here it can produce as the magnetic field lines. Then these magnetic field lines, they are look in the pattern of circular rings, isn't it? So these are the circular magnetic patterns will be surrounded by this straight current carrying conductor. Then now we have to find out how actually the direction of this magnetic field lines. So for that, which law we can use? Of course, we can use by the right hand thumb rule, right? Here is the right hand thumb